Hello, today Xiuru and I from the UMTRI Bioscience Research Group will be presenting the website for parametric human models we have been working on during this summer. A parametric model is a model that can be generated by specifying a certain set of parameters or measurements obtained from humans. Due to increasing life expectancy and decreasing birth rates, the growth rate of elder population is increasing, and it is still going to continue for the next several decades. In addition, according to the World Health Organization, the rate of obesity has increased significantly since the 1980s. However, the traditional human models for design only account for mid-sized young males, while an increase of the injury risk among vulnerable populations such as small females, elderly, and obese people occurs. Therefore, parametric human models are really needed. Our team aims to create a website that can generate parametric human models by changing the parameters, including age, sex, stature, BMI, and SHS from users. And the output models should be predicted accurately. Not only do we want to allow users to be able to obtain their desired finite element human models in different formats, but also we want to provide a good user interface that makes everyone feel comfortable with using the functionality provided by this website.
In general, a parametric human model can be generated by a combination of the parameters in the baseline model through some calculation of a statistical geometry model. To get the statistical geometry model, CT and body scans were performed from hundreds of human subjects with a wide range of size and shape. Data from these scans were then extracted and processed to predict a statistical geometry model represented by coefficient matrices. The processes included the generalized Procrustes alignment, principal component analysis, and regression analysis. With the statistical model, landmark-based mesh morphing methods, radial basis functions were used to calculate landmark displacements between the statistical model and baseline model. The parametric models were then obtained by updating the baseline model with the displacement data. In our website, we use two statistical models, one for male and one for female, associated with two baseline models to get a parametric model separately for male and female. The equations here are the ones we use to do the calculation in our website. And speaking of the programming languages involved in this project, the coefficient matrices were generated in MATLAB, and the website was developed mainly with JavaScript and Three.js. Our website was built with different controls to the model. If you want to try the website yourself, please feel free to scan the QR code on this page. In simple terms, we can change the perspective or view of the model by rotating it or moving it, or by using the buttons under the View folder on the left panel. Color of the background, color opacity, and visibility of each part of the model can all be adjusted based on users' interests. There is also a reset button if the users want to reset the properties. On the right side, we have another panel where the parameters of the model can be customized. The users can try any combination of the parameters and observe the effects on the model. The users can also save a model with a certain set of parameters and display against the dynamic one. This enables the users to compare two models and see their difference more intuitively. Lastly, the model can be downloaded in LSDYNA, OBJ, STL, or PLY format for the user's own purposes.
In conclusion, we built a website that can generate 20 parts of a parametric human model of various groups of population by user-specified parameters, including age, sex, stature, BMI, and SHS. The users can not only view the models, but also compare any two of them and download them in one of the supported formats. The motivation of building this website is to display parametric models that account for vulnerable populations that traditional human models do not do. In the end, we would like to thank Dr. Hu and Dr. Park for their guidance throughout this summer. We would also appreciate people in bioscience group who provide the baseline models and mathematical equations. This project will not be able to complete without their help. Here are all the references we use for this project. This is the end of our presentation. Thank you.